Hi everyone, this is Bhaskar Ramagiri. I am a research scholar in Aerospace Department, IIT Bombay. I am TA for this course AE 314 and AE 727.
I am going to talk about tensile testing. The first question one would ask is why to perform a tensile test. Tensile test is performed to determine how strong a material is and how much it can elongate under pulling load. In engineering terms, one tries to determine stress-strain response of the material, and the engineering parameters one can obtain out of stress-strain response are Young's modulus, elastic limit of the material, yield point of the material, ultimate tensile strength or peak strength of the material, strain to failure, and stress at which the material fails.
This is an Instron 8800 hydraulic universal testing machine. This is the cross head of the machine, and there we have the piston which drives the grips of the machine. These are the grips. This is the upper grip and this is the lower grip, and this machine is powered by a hydraulic power pack which is at the back of this machine.
To keep the machine within the operational temperature limits, we have the cooling tower which supplies cool water circulation to the hydraulic power pack.
And this is the console of the machine, which is like a controller to the machine, and in that computer we have a software which is called Blue Hill, where we set the test parameters to run the test on this machine. This machine is capable of performing axial tests, both compression and tension. It is also capable of performing torsion. In compression and tension, it is capable of loading till 100 kilonewtons, and in torsion it is capable of loading the specimen to 1 kilonewton meter. The testing machine is also capable of performing fatigue tests. Depending on the kind of specimen, we use different kinds of grips. These are V-faced grips which are used for gripping round specimens, and these are flat serrated grips which are used for gripping flat rectangular specimens. For this course we are going to test flat rectangular specimens, so we are going to use these flat serrated grips. As part of this course we are going to test composite samples, aluminum and mild steel samples. Okay, I am going to start the cooling tower and then the hydraulic power pack, and then command switch on the console and start the application on the computer. Go ahead. Now the machine is in low power mode. This button indicates the machine is in low power mode, and when we switch on the operating mode, this button brights up, and while performing the test we have to keep the machine in testing mode. During that point the last button lights up. These are the controls which are used to position the grips. The upper arrow helps in moving the grip up, and the down arrow helps in moving the grip down, and in torsion these are the grips used to adjust the rotation of the grip, and the bottom buttons are used to unclamp and clamp the specimen in the grip.
Depending on the type of material we are going to test and the availability of material, there are different specimen standards by ASTM and ISO. For this course, we are using ASTM E8 by EM test standard. Now we are going to test aluminum sample. Now we are going to test mild steel sample. Now we are going to test composite sample.
This is the live display of the machine. While performing the test, you can see the extension and load from this display. Now I will show you how to set up test parameters in Blue Hill software. So whenever you are starting a test, you have to create a method for the test. So we are performing the tensile test for this course. So I am selecting a tension method in the method template. Next. So in the specimen section of the application, you can choose different kinds of specimen. As we are testing flat rectangular specimens, I am selecting rectangular specimens, and we can give the width of the specimen, which is 12.5 in our case, and thickness, which is around 5. I am giving thickness, and length, which is the gauge length of the specimen, which is around 85 for our specimens. Then one can go to the test control. So in the measurements, you can ask the machine to measure time, extension, load, tensile strain, tensile extension, tensile stress. In test control, we can use the machine actually in two ways, either load control or displacement control. So in test, if we give the extension, the machine will operate under displacement control, and we can give at what rate the crosshead has to move, or at what rate the specimen have to be pulled. So in this, we can set 1 mm per minute. That means the specimen will be pulled with an extension of 1 mm per minute. Or we can use load. If we want the specimen to be loaded with 10 newtons per every minute, we can give load. So in these experiments, we are using displacement control test, and for the data we have given you, we have used different extension rates. So I am using a 1 mm per minute for this sample. So end of the test, you can decide when to end the test. Either you can manually click end the test, or you can set some conditions for ending the test. So I am using rate of load and percentage peak load. So when the load drops by 40% of the peak load the machine has seen, it will end the test. And in the console, you have a soft keys section where you can drop this balance all, so that before you start the actual test, you can once click the balance all, so that the application will zero the extension and load and start taking the data. In workspace we can add the operator input. For example, we can add specimen features like specimen geometry, specimen length, specimen width, and the specimen thickness. We can also add the extension rate to the workspace. So at some point, if you want to change the crosshead speed, you can change live in the workspace. So in the export section, you can ask the machine to export the raw data. We can also ask the application to export some results, like whatever the calculations you give to the application. So in calculation section, you can ask the application to give percentage break. We can ask the machine to give the yield. We can also ask for Young's modulus. The tensile strength of the specimen. In export raw data, you can choose what all data you want in the raw data file. You can ask for load, corresponding time, extension, and the stress and tensile strain. This will be added to your raw data file. And in file settings, you can choose where your data, where you want to store your specimen test data by browsing to the folder whichever you want. And finally, like once you finish your test parameters, your method, you can save it in the location you want and use that method you created for testing the samples.
I will provide you with the test data of 3 materials: aluminium, steel and composite, and you have to make the following calculations that are given in this slide.